because we have that little like in-class example.
Okay.
Yeah, those are still points.
Okay, before I start the lecture, do you guys have any questions about anything? Homework, class, alkanes, alkynes.
For the homework, is there homework this week?
Yes, I posted the homework yesterday.
Okay.
Yeah. So the deadline would be like usual, Wednesday at 11:59 p.m. So plan accordingly. And if you cannot complete the homework due to an excuse reason, just like communicate that with me in advance. I have some students just like, they write this thorough email to me and I feel bad after all they wrote. I say, no, there's no extension, or I cannot give you makeup. But, remember that when I say, you cannot do it because of an excuse reasons, it's not like that you were busy this week or you had like another deadline for another course or like something happened like Wednesday night, okay? So if you get sick or like have a family emergency and something that prevents you to do the homework during the week. But yeah, I posted the homework yesterday. And the reason it was like kind of later than usual, I was writing like 11 versions of the homework for my 101 course because I realized some of the students were like solving the homework together. So, and I told students, and I told this class too, that you're not allowed to consult with each other. But for this class, I feel like students are listening to me, so I don't need to do extra work to make sure students do what they're supposed to do. I feel like most of you just like do what you're supposed to do. So I'm just like more comfortable with you guys. Anyway, so great question. Thank you for mentioning that. Any other questions about the homework, halogenation reactions, and all that? Everything's good? Okay, so yesterday when I was just like going through the course materials and I wanted to write the materials in advance in my Explain Everything software, and I realized that what I was going to do was like literally write everything from your book. So I just included the book. I think this is like, and it's not legal per se, that I just have like the, one picture of the book, because it has like this copyright at the bottom of the page, or at least these ones that I was like, that you're not supposed to distribute these things. Since I told you guys, I was doing that for my 101 course last semester, but since the publisher gave me access to kind of have the book for all students for free, I thought that it's not a big deal. So I was taking pictures, of the book, and they include that in the slides. And I had some students wrote in the student evaluations that she just like have pictures of the book and just read through them. But this is basically what I'm doing anyway. I just like, even if I write in my Explain Everything software, if I have slides, prepare them in advance, I literally, read the book and then kind of like explain to you what is written in the book, So I feel like the students wouldn't like that I teach them something and I ask something that is not among the things that I explained to them. Anyway, so what I did, I just like explaining you the rationale behind this. But as I told you guys, I expect you guys all to have the book. If you don't have it yet, come talk with me and then we talk about like the options. And however you want to get it, I had some students that they told me that they didn't get it from Cengage or like bookstore, they got it from like Chegg website or like other websites. However you get the book, just get it, okay? So now you have like the nice slide that I put lots of effort in making here too. So can anyone tell me the difference between alkane, alkene, and alkyne? Yes?
Single bond, double bonds, and triple bonds.
Exactly. And we had like in general 2 categories of hydrocarbons, whether they were like saturated or unsaturated. Does anyone remember which ones were saturated among the ones that your friend just mentioned? What's that? Alkanes, single bonds. So if they are like, your hydrocarbon have only single bonds, we call them saturated. If they have like double or triple bonds, we call them unsaturated. So can they have like more bonds? Like, can we have a compound that has like 4 bonds, or like, can we have a compound or hydrocarbon like this, that they have like more than 3 bonds? Why not?
Too many electrons.
Too many electrons,
They don't have those.
right? The valence of carbon is what? Can anyone remember? 4, right? So it can have maximum 4 bonds. So that's why we just talk about single bonds, double bonds, triple bonds, because when we want to have like, different, bonds between carbons, so this is possible because we can have 4 bonds total, right? 1, 2, 3, 4. Or, for instance, if I have like this, right? This is also possible between these two. If you consider this carbon, it can have like 1, 2, 3, 4 bonds in total. But more than that, we cannot have. That's why we just talk about single bonds, double bonds, and triple bonds. Okay? So here, this one, we talked about before, that if we have like the general formula of like CnH2n, we can have an alkene. And if we have like CnH2n minus 2, we'll have alkyne. And do you guys remember what was CnH2n plus 2? Alkane, exactly. And again, when I was like refreshing my memory about like these, compounds and like naming them and all that, I was reminded that this course is just lots of memorization. So it's like, organic chemistry is basically you read through compounds and remember which is which. So I encourage you to, as I mentioned several times, just when I teach you something, go back home, study them before the next class, because now next class we'll be having lots of more things to memorize. So when you progress with the class, it would be much easier. As you see, if you learn alkanes, now we added like 2 other categories. So it would be like easier if you just pace the study. And in general, if we have like alkene and alkynes, as we said, we call them unsaturated because they have fewer hydrogens per carbon, right? So if you have like, for instance, CH4, or like I guess I make an example of C2H6. If I have an alkane, and now if I have like the equivalent, so what do we call this? Ethane, right? So if we have like the equivalent alkene, I should write C2. What would be the exactly CN H2N would be alkene, and we call that ethene, right? So, and if I write the equivalent alkyne, right, what would that be? C2H2, right? Would be ethyne. So you see that now we have like less hydrogens per carbon. Any questions so far? Are we good with this? And now if we have like alkenes or alkyne, if we add hydrogens to them, we can get the alkane again. And depending on whether we have like alkene or alkyne, so you see that, alkynes have like less hydrogens. So we should add, for instance, 2 hydrogen molecules in order to get the alkane. But if we have like alkene, we can just add 1 hydrogen molecule. And then we need a catalyst to do these kind of reactions. Does anyone remember, or do you guys know what is a catalyst? Anyone remember or studied before?
Hydrolysis.
Sure, yeah.
It kind of like kickstarts a reaction.
Yes. So they accelerate the reaction without being consumed in a reaction, right? So if you have like platinum catalyst, for instance, I mean, I'm just talking about like a general reaction, not about these specific reactions. But in general, if you have platinum as a catalyst, it accelerates the reaction that you're studying, but it doesn't bond with the reactants or products itself. It's just intact. It won't participate in the reaction, but it accelerates the reaction. Because you see the word catalyst, I want you guys to know what it is. But right now, we're not dealing with catalysts and what we're studying. Any questions? And here, again, I'm going to ask you in your homework problems, quizzes, and all that from like this, text that you see in the edge of your book. So just to study those as well. So here, basically, it's just like summary of what we said, that we have like unsaturated hydrocarbons, and then they include, alkenes and alkynes. And also here, okay, I guess first I talk about like, alkadienes or like dienes, and then talk about like, this, I talk about this afterwards. Okay, so do you remember that when we were studying alkanes, we said that, carbons have this ability to just like form a chain, and we have like carbon-carbon bonds. Do you remember what we call that? Catenation, exactly, right? So now that we have like double and triple bonds as well in the compounds that we're studying, it's the same, we still can have like carbon-carbon bonds, but some of them can be double bonds, some of them can be triple bonds. And depending on what is the arrangement of these bonds, we name these compounds different things, okay? So one type, and again, remember that now we introduce double and triple bonds. So this is what we are focusing right now. So if we have like double bonds that they are like next to each other, right? We call them cumulated, like accumulative. I always encourage you to just like linguistically look at the words like cumulated. It means that you have like two double bonds next to each other. And now let me ask you this. Can we have like this triple bonds next to each other like this? No. Why? Exactly. You can consider electrons, as your friend said, or like bonds, right? So here you have like six, the carbon has like six bonds, six single bonds in a sense, two triple bonds, or it can, 2, 4, 6, basically 6 bonds multiplied by 2, or like 12 electrons. And you know that carbon reaches an octet. It can have maximum 8 electrons or 4 bonds. For that matter, we cannot have this. That's why when we talk about cumulated configuration, we can only have double bonds anyway. That's why. Does that make sense? So here is like definition that we call double bonds cumulated if we have them next to each other, when they are next to one another. But if you have like one double bond and one single bond, and then one single bond, one triple bond, or basically when you have like double triple next to a single bond, kind of like this configuration here, we call that conjugated. And as I said, these are again, if you look at the word itself, it makes sense, but bottom line is that there are like just definitions. We should just remember them. Okay? So when multiple bonds, and your book calls like double or triple bonds, in general, multiple bonds. So instead of saying like double bond, triple bonds, I keep repeating them, I just say multiple bonds. If multiple bonds alternate with single bonds, we call them conjugated. Okay? And lastly, if we have like the combination, meaning that if we have like a multiple bond, right, and then we have a single bond, and then we have like single bond, it's kind of like we don't have like a multiple bond, single bond, multiple bond, you know. We have like, we separated these multiple bonds with more than one single bond. Or like as your book said, when more than one single bond comes between multiple bonds, we call them non-conjugated or isolated, because as if these like multiple bonds are isolated in a sense, they're like far from each other. Any questions? Does this make sense? Yes.
Non-conjugated.
Uh-huh.
Does it have to be the same, like triple and triple
No.
bonds isolated, or can it be double and triple?
You can have like one double here, and then this one would be triple. Or like, for people who are at home, this one can be like, for instance, double like this, and then you have like several single bonds, and then, you know. But here, if you have like this configuration, you can, you know, other things are also going on here. Like you have like, you know, two branches, or like you have like non-paired electrons and so forth. But if you just like consider, so yeah, they can be. But again, you know, remember that the valence of carbon is like 4. So when you want to write the compounds, you should consider that. And then you have like an example in your book that now, you know, it's a good time for me to talk about. This one, you mean this one? Or like in general?
In general.
So in general, if the multiple bonds are like next to each other, we call them cumulated. If they're like alternating, like multiple bonds, single bond, multiple bond, we call that conjugated. And if between them are like, you know, multiple, 2 or more single bonds, we call them non-conjugated.
Right.
So-
But the top conjugated carbon chain, it doesn't fill like the valent shell of carbon.
Okay. So you see, we don't. Oh, you mean like. Oh, this one?
Yes.
So here it's just like their structure to demonstrate the point. It's kind of like what I was writing here too, you know, that you have other things going on in the compound, but here it just shows you the point that is demonstrating. Does that make sense? So these compound, you just don't see this as such, you know. You have like hydrogens, or you may have like branches, you have like other things going on. But it just like tells you, when you see those structures, just focus on carbon-carbon and what type of bonds are between them. Great question. Any other questions? Okay. Example. So this is like example. So I write example 2. Example 3.1, that it says, what are all of the structural possibilities for the compound C3H4. Okay. So, if we want to write this, what are the possibilities? So, we have 3 carbons and 4 hydrogens, right? So, if I just have like all the bonds as single bonds, what would be wrong with this? So if I write this, right? I guess the first thing that we see is that we have like 3 carbons, right? So we know that we should write 3 carbons. But if all my bonds are single, and I write this, what is wrong with this structure? Is this what question asked me? No. Why? What is this one? Exactly. This is propane. So this is not C3H4. So how can I get C3H4? What can I change in this structure? So what can I change in this structure to get C3H4?
Double bonds.
Double bonds, right. So what if I put a double bond here? So remember, how many hydrogens should I put here? How many here? One, right? How many here? So did I reach C3H4? How can I change this?
Add another double bond.
Yes, so one possibility is that if I add another double bond. So how many hydrogen here? Here, here, 2, right? So this is one possibility, and your book wrote this as this, H2, H2. And whichever of these you write in the exam, I'll accept. And except, I mean, sometimes I'm indecisive. I think maybe it's better to give you guys some homework problems that you have to actually write compared to like being multiple choice. Maybe it like increases the learning, but then it becomes like much more difficult for me to grade. So for your exam, for sure, you see like multiple choice questions, but you should know how to write these things too, because in your homeworks I may start like asking you to write these structures, but regardless, whichever of these two you write, that is acceptable. Okay? Or like if you have like you put the H2s not exactly like this, as long as you know that you have like 2 hydrogens attached to this carbon, that's fine. So I won't be strict about that in a sense. So is this the only possibility? What is the other possibility? Yes, exactly. Did you want to say the same thing? Okay. So I put like 3 carbons because I have like, I guess here, C3H4. So this can be another possibility, right? If I write this, how many hydrogens should I have here? How many here? How many here? 3. And your book wrote this as, and this is basically the same thing as we wrote here. It's just kind of like basically this equivalent of what we wrote. CH3. And these 2 structures, these are the same. They're not distinct, because if you just rotate them, you get the other one. Does that make sense? For that matter, you can put the triple bond whether here or here and write the corresponding structure. Those are like the same. So do you guys can think of any other structure rather than these 2? What about I put these in a ring, right? Can I get again like somehow C3H4? How can I get C3H4 if I have like this base structure here? What's that?
One single double bond.
Exactly. Right? So if I have that, how many hydrogens here? How many here? How many here? And your book wrote this as, so 2 hydrogens, and then 1 hydrogen here, 1 hydrogen here. But again, as long as you have like this structure, that's correct. So you can put like hydrogens like different directions here too, as long as Yes.
And the last 2 were conjugated, right? Whereas the first one was cumulative.
So the first one here, yes, exactly. So this is cumulated, and then this one, yeah, so they're like alternating, yes. Any other questions? Yes.
So on the last slide where it was showing conjugated, it had the 4 carbons and then a single bond and a double bond. But then that wouldn't complete carbon's like valence shell. So why does it work like that?
So the last. Okay, so are we good with this example? Does this make sense? So when I give you a compound, I tell you how many structural isomers they may have. And in the exams and homeworks, I mostly talk about like structural isomers, as I said, because we didn't practice that much, conformational isomers and all that, But for structural isomers, we kind of like talked about them more. So I will ask about them more. Okay. Let me, if we're good with this, start talking about nomenclature. And do you guys remember, can anyone tell me the rules that we used for alkanes in general?
Longest chain.
Exactly, longest chain. What was the next one? So imagine we found the longest chain. What would we do next?
Closest branch to the end.
Exactly, we would name the carbons and we would name them somehow that we reach the branch first, okay? So what if we had like 2 branches? What would we do next? Yes?
The one that has the most, or like the most of the element.
So, what's that?
Alphabetical.
So alphabetical was kind of like the last thing that we would look at, right? Imagine I had like if I had a compound like this, right? And then here I had like, CH3, and then here I had like CH3 too, right? So, should I go? Yes, I go left to the right, right? Because I want to reach the branch first, right? Do you remember? And then what if both of them were the same distance, and then I had like the 3rd branch? What would I do next? Does that make sense what I'm asking?
The one that's closest to the 3rd branch.
Exactly. So you would go left to right and right to left, and then whichever that gave you the smallest number for the 3rd branch, you would go that direction. Yes?
But in this example, isn't that CH3 part of the continuous chain? So wouldn't you want to start from right to left?
Exactly, yeah. Yeah, great catch. Yes. So this would be actually your longest chain. So I kind of tricked myself with the questions that I asked. Is the following name true or false? So this would be like, yeah, great catch. So here, as your friend mentioned, so this would be your longest chain. Do you guys see what he said? So this would be your longest chain. So for that matter, we go this direction. Yeah, thank you for mentioning that. But I guess the good example for what I said previously would be if I have like this structure and then one CH3, one CH3. Let's see. So 1, 2, 3, 4, 5, 6, and that is the longest chain, right? Okay. So this is like a relevant example of what I was saying before. So here, should I go left to right or right to left? Left to right, right? Okay, great catch, thank you. Okay, now if I have like, imagine if, I have like another. So here, imagine if these 2 methyl groups were the same distance and I had the 3rd branch, I would go from the direction that I meet the 3rd branch sooner, right? Is that clear to everyone? And now imagine that everything is the same. You know, I could go left to right or right to left. All the branches were the same distance. I didn't have the third branch, or even the third branch was there. I could again go from those directions. In that case, if everything was the same, I would go alphabetical, right? So if you had like methyl and like diethyl, although even you have like diethyl, we would consider ethyl and methyl. Or like bromo and like methyl, we go with bromo, right? So these were like in nutshell the rules that we studied for alkanes. Now for the, you know, when we have like double bonds and triple bonds as well, we're adding more rules. So the first rule is that you should choose the longest chain that has multiple bonds in it. So here you should go with the left longest chain, this one, because it has a double bond in it, not this one. Okay? Any questions? So the second rule is that you name from the direction that you reach the multiple bond sooner. So here, if I go from, you know, left to right, and then I call this 1, 2, 3, 4, 5. In carbon number 2, the carbon number 2 is attached to a double bond. And you consider, you know, the first atom that is attached to a bond, to a multiple bond. Does that make sense? And here, if I go right to left, you know, if you name 1, 2, 3, the third carbon is attached to a double bond. Since this one has the lower number, you go left to right. Any questions? Is that clear so far? Okay. The next rule, you know, is that, or like kind of like stop, you know, one part of this rule, or an extension, if you will. So if you have like, you know, here, if I go for this structure here, 1, 2, 3, 4. If I go left to right, I encounter, you know, the second carbon. So the number of this carbon that is attached to a double bond would be 2. And then here, again, would be 2 if I go right to left. So if the multiple bond is equidistant from both ends of the chain, number the chain from the end nearest the first branch point. So here we have like a branch. So it's kind of like similar to what we studied before, right? So we go from the direction that we encounter the branch first. But here we had like, because we have like, you know, multiple bonds, we had like 2 more rules before branch. Does that make sense? So when you want to name unsaturated hydrocarbons, you should first think about multiple bonds and then think about branches. Okay? So we go from like this direction, not this one. Even here, you know, we had like, I would say that, okay, the second carbon is attached to a double bond. So here you have another carbon too, right? Carbon number 3 is also attached to a double bond, but we use the lower number carbon when we want to name these unsaturated hydrocarbons. Does that make sense? Here, the first rule was like the thing that we all mentioned before, that we have like, you know, if you have like double bond, the ending would be in, like alkene, right? And then if you have like triple bond, we have like, you know, where is it? Ine. And there is another one as well, you know, here that I'm going to explain during the next class. The other ones that if you have like multiple ones. Yes?
Back on the assigning double bonds, that's...
And now, you know, the next rule. We want to, so far it was like naming the carbons, going to know, you know, which direction. And now we want to, you know, name them, right? So we indicate the position of the multiple bonds using the lower number carbon. Imagine, remember that, okay, so we use the lower numbered carbon. So here, so should I go left to right or right to left? Right, because you encounter the double bond sooner. And then you name these carbons 1, 2, 3, 4. And now, remember, this structure is like this, right? So double bond, C, 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 right? And then it would be like H2. This would be H. This is like H2. This is like H3. So we call them 1, 2, 3, 4. So carbon, although both of these are attached to a double bond, we use this carbon. We say 1, right? And then again, we write a dash. And you have how many carbons do you have? 4, right? So you call this butane. Butene. So it would be 1 butene, not 2 butene. Because we use the lower numbered carbon. Any questions? Good. Okay. If more than one multiple bond is present, number the chain from the end nearest the first multiple bond. So again, here, remember, we really care about these multiple bonds. And then we have the rules, or the chemists have these rules so that they take care of multiple bonds. So here, again, if I name this from this side, you have 1. So the first carbon that you encounter attached to a double bond, right? But if I go this way, you encounter the second carbon, So if you name from right to left, the carbon that is attached to a multiple bond would be 2. The first one that you encounter here is 1. So for that matter, we go from this direction, not the other direction. Is that clear? As I said, it's just lots of rules that you should just remember. And the only way to become good at this is just solve more and more examples. If a double and a triple bond are equidistant from the end of the chain, the double bond receives the lowest number. So again, these are the rules you should remember. Sometimes, I don't know, you may think that it's just the other way around. I don't want to repeat it to kind of establish as in your head the wrong answer. But if you have double bond and triple bond, and then you encountered them, if you name the carbons, the number of carbon would be the same. You go from the direction that double bond has lower number. I guess it kind of makes sense, right? If you have double bond, you want the number for double bond be lower than triple bond. It has 1 single bond less, 1 bond less as well, right? So you want the number be lower. So however you can remember the rule. So here, if I go from left to right, I say 1, so I encountered a carbon that is attached to a multiple bond in a carbon number 1, and then if I go this way, right to left, I also encounter the carbon number 1, right? So I can go both directions based on the previous rules that we studied, but we go this direction because we want the carbon attached to a double bond we want that to have lower number compared to the triple bond. Does that make sense? Any questions? Yes?
Can you just repeat that one?
The last one?
Yes.
Okay. So you see, one of the rules that we had was that when we go, we want to go from the direction that we encounter multiple bonds sooner, right? So, for instance, here, we didn't go from right to left because if we go that direction, we would, this carbon would be number 4, but it has multiple bond. We want the carbon that is attached to a multiple bond has lower number. We want to encounter that first, right? Mm-hmm. So here, if you have like, double bond and triple bond at the same time, so let me write this here. If you have like this, right? If I go left to right, I name this 1, 2, 3, 4. So I encountered a carbon that is attached to a multiple bond in a carbon number 1, right? And now if I go from the other direction, right to left, again, 1, 2, 3, 4, I encountered the carbon that is attached to a multiple bond, again, the carbon number 1. So both of them, technically, based on the previous rules, can be the same, right? So you may think that both of these are correct. But now we have another rule, that if you have like double bond and triple bond, and then the other rules are met, and then you can go from either direction, we name the carbon somehow that the carbon with the double bond, or like lower number of bonds compared to like triple bond, that one has the lower number. So if I go, left to right, and then let me go back to the red. If I go left to right, I have like 1, 2, 3, 4, right? So this carbon that is attached to the double bond would be like 1, the number, right? So this is for like double bond. And then the one that has like attached to the triple bond is like 4, right? Triple bond. But if I go from like right to left, the carbon that is attached to the double bond has like number 4, right? Double bond. And then the one that is attached to the triple bond is like 1. So in which of these, the purple one or red one, double bond has lower number? Red. So that's why we go with the red, not with the purple one. Does that make sense?
Yep.
Okay. Great question. Any other questions? Oh, and the first rule here, where was it?
Both equidistant from the end, correct?
Yes.
Now,
Here.
What happened? Yeah.
Uh-huh.
If they're both equidistant, what if they're not equidistant? Is it just whichever one you hit first is still a sign?
Exactly.
Okay,
Yes.
all right.
Great
Making
question.
sure.
What's that?
Just making sure.
Okay, yeah. Yeah, just ask the questions, because sometimes the questions that you ask, first of all, they're great questions, and sometimes your other classmates have the questions too, and then now you ask, they know the answer too, so just like ask any questions. Okay, now let's do an example. So, okay, let's have, and I encourage you guys to first write this yourself before I write the correct answer. So how do you guys name this compound?
Find the chain that has the double bond in it.
Exactly. Right. Oops. I meant to have the highlighter. Okay. So this one, right? And then you should have like the most number of carbons, including multiple bonds, right? So that's why we shouldn't just choose any other carbons, right? I just don't want to crowd the picture, right? That's why you wouldn't choose like this one, for instance, right? Because that one doesn't have a double bond. You want to have the double bond. Let me just erase this thing that I wrote here too. Okay. So now if I want to name this, should I go left to right or right to left? Left to right, right? Is this clear for everyone? Why? Why? Exactly, you want to encounter double bond soonest as possible. Okay, so now, what is the base name of this compound? Exactly. Butane, right? Because you have double bond, right? And now, what group do you have here? Methyl, right? So we write methyl as well. And now remember, in these compounds, you need a number to assign the branch that is attached to your compound and a number to assign the carbon that is attached to a multiple bond, right? So your butane, you attach a number to it to say that the double bond is attached to what carbon. And as we said, you have like two bonds in general, right? You can, you have like, this carbon and this carbon both are attached to a double bond, but we use the one that has the lowest number, right? So here, which carbon is attached to a double bond? 1, right? And which carbon is attached to a methyl? Right? So we call this 2-methyl 1-butane. Is that clear? Okay, next session I'm going to go through like more examples and continue with naming alkenes and like alkynes. But I asked you guys to read these materials before next class, so when I add like names, it won't be like confusing. No, I don't. Thank you. Now